It's 3 o'clock already, so let me open the PowerPoint. Okay, so where were we last time? We started this new chapter, which is wave properties of particles. Okay, तो उसमें थोड़ा सा मैंने आपको डी ब्रॉगली वेवलेंथ का एक्सप्लेन किया था, हमने कुछ थोड़े से एग्जांपल्स किए थे, उसके बाद हमने क्वांटम मैकेनिक्स के थोड़ा सा वेव फंक्शन थोड़ा सा इसमें आ गए थे, but we will do a whole chapter on quantum mechanics using the psi as a wave function. We will be doing this in our next chapter. For today, we will be continuing with this chapter, which is the wave properties of particles. So we will be talking about phase velocities and group velocities, and I will tell you what the difference is between them. We will be doing some mathematics regarding these velocity expressions for wave functions and velocities. Okay? So now we're saying that if a particle that's moving can be represented as a wave, okay? So we have the wavelength of the particle of the wave we have the wavelength, the de Broglie wavelength of the wave that the particle can be assumed to be its nature, the particle can have wave-like nature. So the de Broglie wavelength is a measure of its wavelength. So then how do we, since we associate de Broglie wave with the moving body, we expect that this wave will have some velocity. We already know that if we draw a wave, okay? If we draw a wave and it's moving, this is not to scale, but if it's moving, we can have a velocity in the, suppose in the positive x direction, if this is the x direction. Okay, so we can have the velocity, the wave can move in the positive x direction, then it would have a velocity. So we have to talk about phase velocities and group velocities, and I will tell you what the difference is between them soon. So if we call de Broglie wave velocity Vp, which is the phase velocity. So, and I will tell you shortly what we mean by phase velocity, but before that, I said that velocity is given by what equation? Frequency into wavelength. Yes, velocity of a wave can be represented by frequency into wavelength. So if the wave is an electromagnetic wave, then we said that C will be equal to F lambda, and that's how if we already know what the speed of light is, and if we know what the frequency of a certain wave is in the electromagnetic spectrum, we can calculate its lambda, its wavelength. So here we're talking about de Broglie waves, and lambda here is equals to h over, if we're talking about the relativistic momentum, then we said before that lambda is equals to h over p, so the relativistic momentum is gamma mv. So we have this formula for the de Broglie wavelength, lambda is equals to h over gamma mv. So now if we want to find, what do we want to find? We want to find the frequency, okay? We don't know what this frequency, we want to find the frequency of the wave, and if we know what the frequency of the wave is, why are we interested in finding the frequency of the wave? This is de Broglie wavelength. We want to know what the velocity of the wave is, okay? So velocity of the wave is frequency into wavelength, और de Broglie wavelength हमने already कह दिया कि ये है. The frequency हमारे पास अभी तक नहीं पता चल रहा कि what will be the frequency of the wave? How will we determine that? So we know that now we're talking relativistically here, okay? We're talking relativistically here. So what I'm saying here is that we know this equation holds. इससे हम phase velocity determine कर सकते हैं. What is this? Phase velocity determine कर सकते हैं if we know what we already said, that we know what the de Broglie wavelength is for the wave. But what about the frequency? So we know that E is equals to, do you prefer using nu or F? I prefer using F because nu is like, it looks like velocity. So E is equals to HF. Yeah, so E is equals to HF. That is our energy of the photon. ठीक है, हमें पता है कि energy of a photon is given by E is equals to HF, ठीक है? And relativistic energy is gamma mc square, right? Gamma mc squared is a relativistic energy. So if we make that equal to hf, can we rearrange this formula and say that hf is equal to gamma mc squared? So the frequency will be gamma mc squared over h. ऐसे कह सकते हैं हम? We can say that. So the de Broglie wave velocity will be the phase velocity, the de Broglie phase velocity is equals to frequency times wavelength, and frequency is given by this formula and wavelength is given by this formula. So when we just put those, multiply those two together, we'll get c squared over v. However, there's some problem with this expression, and it's not, we are saying that the particle velocity must be less than the velocity of the speed, the velocity of light c. Okay? So if this is less than c, then we have c times c divided by something less than c. What is that going to give you? That will give you a number greater than c. So then that means that de Broglie wavelengths will travel faster than light. That's a contradiction to us, because we're saying that nothing can travel greater than the speed of light. So this is an unexpected result, and in order to understand, we have to define something called phase velocity and group velocity, and we have to understand the difference between what do we mean by phase velocity and what do we mean by group velocity. So I will show you a small video. Actually, the video comes later on. One student is saying connection nahi ho raha. Maybe I should invite him to join. यहाँ पे नजर ही नहीं आ रहा. I don't know what to do. Make an attendee. मैं कैसे सबको attendee बनाऊं? Okay, well, I should continue here. One student is saying उसकी connection नहीं हो रही है. I don't know what to do. Okay, हो गया.
मैम हो गई है.
Okay, good. Okay, so as I was saying, that there is something we have, because when we calculate the velocity of the velocity of the wave, when we calculate the velocity of the wave using frequency times the de Broglie wavelength, using these expressions, we get c square over v, and this is actually v will always be less than c, so which gives us something, the velocity of the wave will be greater than c, and that's not possible. So we have to describe something called phase velocity and group velocity, and we have to be able to distinguish between what do we mean by phase velocity, what do we mean by group velocity. So phase velocity is actually the wave velocity. So I will show you a small video over here. I won't show you the whole, but only where the part that is relevant. So can you see all this this green dot and this pink dot, magenta dot here? So if you can see, this video, these waves over here, I will just pause it for a minute. This green dot over here is representing the wave velocity. The wave, the whole wave is moving at this velocity. And the group, we have a group, which, have you studied about beats before? So we will also go into that. So if you have, this is like superposition of waves. We get something that looks like this when we superimpose two different waves together. Okay? For example, this wave and this wave, when they're superimposed together, we'll get something that probably looks like this. Okay? In which we have a group of waves. So the green dot, the magenta dot over here is a group velocity. And I will show you this. It's the velocity at which the whole group is moving. The magenta one is the velocity at which the whole group is moving. And the green one is the velocity at which the wave, which is like the outer boundary of this whole, we don't consider this separate group, but we consider the whole wave. Is this making sense? The difference between group velocity and phase velocity? We will go more into the mathematics of that, but before, I just wanted to show this video because I wanted to make, yeah?
मैम इस तरह से कि फेज वेलोसिटी जो होती है वो एक क्रस्ट या ट्रफ को पकड़ के उसका देखते रहते हैं कि क्या
Yeah,
वो किस तरह से मूव कर रही है
yeah,
और ग्रुप
like
में ओवरऑल
here,
पूरी
like
वेव का डायरेक्शन.
group velocity over here is like ये जो group move कर रहा है उसकी जो velocity है, and but the wave velocity is the whole wave, the boundary of the wave. I mean it's a bit like you have to understand this visually, like समझ में आ रहा है like किस तरह से visually हो रहा है, like
Yes,
yeah, the green dot is the phase velocity, like it's the velocity of the wave basically. The group velocity is the velocity of the whole group. जो group representation है इसकी, that the whole group is moving with a given velocity, that is the group velocity. So I will go back over here, and the reason why we have to distinguish between phase velocity and group velocity is because we're saying that we just calculated the phase velocity and that is greater than the speed of light. We cannot have anything greater than the speed of light, so we need to distinguish between phase velocity and group velocity. To do that, we will do some calculations regarding waves. So let us begin by reviewing how waves are described mathematically. Does anyone know how do we describe a wave mathematically? Like we can say, for example, y is equals to a. You can take sine or cosine, for example, जो इस तरह के waves होते हैं. Like for now, let's consider the cosine wave, ठीक है? So a cos omega t कहते हैं ना, omega t plus some phase factor, but for now, just ignore the phase factor. We will figure that out soon. But cos omega t is an example of a wave equation. You must have studied waves and oscillations at some point, so you would have known, you would have encountered these equations. And इसमें omega क्या होता है? 2 pi f. 2 pi, times frequency. ठीक है? F is the frequency of the wave. So omega is 2 pi f, and then we have A is here the amplitude. A is the amplitude of the wave, which is this distance. ठीक है? And F is the time. I already defined these terms before. F is 1 over T, and T is the time it takes to make one complete oscillation, which is from here to here. Time, that's the time period.
मैम
So,
एक्सक्यूज मी
yeah?
मैम जब ओमेगा को आप 2 पाई एफ पुट करेंगे और एफ को आप टाइम का रेसिप्रोकल लिखेंगे तो वो टी और टी कैंसिल हो जाएंगे.
Wait a minute, let me check what you're saying here. Omega ko agar 2 pi, if omega is 2 pi,
F and F will be replaced by 1 over t. Then
yeah, then omega
time
is
to
2
time.
pi over t. It's basically saying that, for example, if a wave is moving, takes 2 pi, like one complete revolution is 2 pi, right? And that is moved, it's like angular velocity, like 2 pi radians you move in a time interval, which is the time period. Yes?
मैम
You move 2 pi
मैम
radians in this time, yeah?
ये मैं बता दूं उसको, ये पूछती है कि टी और टी कैंसिल हो जाएगा तो यूनिट लेस हो जाएगा. ये इसलिए
T
हो
or
रहा है
T
क्योंकि
कहाँ
इसमें
से cancel?
हाँ वो
Oh,
इसलिए
here,
हो रहा है.
yeah.
हाँ ये इसलिए हो
So
रहा है क्योंकि इसमें एंगल पुट करना है हमने. तो एंगल तो वैसे ही मतलब कॉस डिग्रीज होगा ना, कॉस कोई एंगल होगा ना, कॉस थीटा होगा या कोई ना कोई एंगल होगा. तो एंगल तो वैसे ही यूनिट लेस होता है, तो ये टी टी इसलिए कैंसिल होते हैं.
2 pi over t, अगर ये w 2 pi angular velocity 2 pi over t है और ये time हमारे पास t ये है t, so it'll be a cos t over time, so it will be obviously cos of it will be unitless, right? I mean radians तो unitless ही होता है ना?
जी मैम.
बट मैम साथ एम्पलीट्यूड नहीं होगा मीटर्स में कुछ.
Amplitude meters में हो सकता है, yeah, but this is unitless.
तो यूनिट्स बैलेंस हो
And
जाएंगे ना,
this is
वहाँ भी
also y
मीटर
is
होगा और
also
वाई भी मीटर.
displacement, right? Y is also displacement.
यस मैम समझ आ गई है.
ठीक है?
मैम
So
टी
what
ये दोनों टी सेम होते हैं, मतलब जो नीचे जो
same
टाइम
तो
पीरियड
नहीं
होता है.
होते, सेम तो नहीं होते ये
तो
दोनों
मैम सेम
चीज.
नहीं होते तो कैंसिल नहीं डायरेक्ट फॉर्मूला में हो सकते ना.
Like for example, time period will be fixed for a given wave. For example, if the wave
एक टाइम पीरियड है और दूसरा टोटल टाइम जो है जितनी देर
total
वेव
time,
ट्रेवल की है.
yeah.
मैम जो स्मॉल टी है वो टोटल टाइम है जिसमें वेव ने ट्रैवल किया है.
Yeah. T is like, for example, if I show you this diagram over here, T is the total time that the wave has moved. For example, if it started over here, 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 A is the amplitude and minus A is the negative amplitude in the negative direction, Y direction, and then T is the total time it has moved, right? And but capital T is the time period of the wave, the time of one oscillation. So T over T is not necessarily 1. ठीक है? So that's why this cause जो है, it's not necessarily going, like if this is not necessarily, T and T won't necessarily cancel, so it's not going to be necessarily cos 2 pi. I mean, it'll have a range of values, right? Depending on our T. T is constantly increasing. T is constantly increasing. So we will get a range of values for this. And so the amplitude takes a range of values. This is continuity. We have continuity here. This is not discrete. Make sense? So as I was saying before, so a wave can be represented by y is equals to a cos 2 pi ft, which is omega t basically. And this is when we say that a wave is represented by this equation in this form, this is simple harmonic motion. You must have heard of simple harmonic in character, okay? So for example, if time is 0, what's going to happen? Cos of 0 will be what? Cos of 0 is 1. So at time t is equals to 0, we have amplitude, which is a. Because when we put cos of 0, which is 1, we get y is equals to a. Y is also in meters or like any unit of distance. So y is also in distance unit and x is also in distance unit. So this is versus x. This graph is y. This graph is y versus x. This graph is y versus t. Okay? So this is, for example, if you have a wave in a stretched string. Okay? So you will just stretch the string. You will just pull it up and down. So then oscillations will appear in the wave. And this is telling you its displacement with respect to time. This is for t is 0, and this is for time that's moving, and x is 0. Is this making sense? And at x is 0, it has a maximum displacement. Maximum displacement is given by the amplitude. Amplitude is defined as the maximum displacement. So now A is the amplitude of the vibrations, the maximum displacement on either side of the x-axis, and nu is the frequency. So this equation over here, this equation here, what does that tell us? It tells us that, is this recording? Yes, okay. Yeah, okay. So it tells us that the displacement point on the string is the function of time. Okay? So this time, small t, is not the same as capital T. It can be equal to, when t, it can be equal to capital T, but it's not going to be always equal to that. Okay? That's why we will get a range, a continuum of values for y. Okay? At different times. For this, this is for at time t is 0 at different x's, and this is for at time t is varying at given x. So, so what we're saying is a complete description. However, if we want to describe a wave, we should tell we want its description in terms of y. What we want y in terms of x and in terms of t. So what we want is a formula that gives y as a function of both x and time. So how can we do that? We want to find a formula, like you must have heard of this formula. Let me clear this. You must have heard of this formula. Y is equals to a cos omega t minus kx, right? Yeah, omega t minus kx. ये आपने सुना हुआ होगा इस तरह का कोई formula, right?
Yes, ma'am.
Yes, ma'am.
We derive this formula. We want to be able to derive this formula, and because right now we only talked about this part. We didn't mention this part yet. So we want to express the vertical displacement in terms of the time as well as the distance, the horizontal distance. Y here is our vertical distance in terms of amplitudes, etc. In terms the vertical displacement of the wave, and X is the movement, its motion along the horizontal direction. Is this making sense? Like if you throw a stone, in water, then the waves will go up and down, right? The water waves will go up and down. Basically, this is the direction of motion of the wave. But the particles, the individual particles, they're moving up and down like this. So this is our y direction. This is our y direction in which direction we get the amplitudes, the highest and the lowest displacement in the y direction. But in the x direction is where the direction along which the wave is moving. Okay? So we want to derive a formula for y in terms of time and position and the horizontal position. So how we can do that?
मैम y और a सेम नहीं होगा?
Sorry, pi or a?
y और a.
Y और a नहीं. Y और a बिल्कुल भी same नहीं होंगे. They will be same at this point when y is equal to a, like this point over here. यहाँ पे और यहाँ पे. For example, in this graph, and here and over here, here and here, y is equal to a. Here and here, y is minus a. Here and here, y is minus a. And over here, it's taking a range of values. The rest of it's going to take a range of values between a and minus a. Here it's 0, here it's 0, 0, 0, 0. Okay?
That's fine.
So now we want to derive this the formula for y in terms of time and position. So how are we going to do that? So if x is 0, we know like this is our starting point. We're taking x is 0 here. And after a time t, which is equal to t, we are making the assumption that at a time t is equal to t. Can you see this diagram? It's very small. Okay, so over here at a time t is equal to t, the displacement, the y displacement, it started off as 0. The y displacement, what did it start off as? 0 here. It started off as 0 y displacement, and here back at time t is equal to t, there will be a point when it will have a 0 displacement. Like you can see 0 displacement here, 0 here, 0 here, 0 here, 0 here, 0 here, 0 here. So we're saying that in this time interval t, how much distance would it have moved? This distance, that horizontal distance it would have moved in time t, is given by the phase velocity of the wave. The phase velocity of the wave, which is frequency into de Broglie wavelength. We just said that the phase velocity of the wave is the velocity of the wave at which this wave is moving in this direction, the horizontal direction. Yes? So the phase velocity into this time t will give us the x, the distance that it has moved from here to here. And because it's displacement, what they're saying here is that the displacement y of the string at x over here, this distance is the same as at any time is the same as the value of y at x is equal to 0 at the earlier time. So what they're saying here is that if we consider this time t at which the displacement is again 0, then what is t minus, like we're saying x is the distance it has traveled in a time t, so x is vpt because v is the velocity of the wave. So then what is time? Time is x divided by vp. So t minus x over vp, what will that be? Is it making sense?
मैम वो टाइम होगा जब उसने स्टार्ट किया था वेव में ट्रैवल करना.
Yeah,
T
this
minus.
is the amount of time. This is the amount of t is the amount of time it's taken to come back to a. I mean, it's not like the first time, the second time is coming to a 0 displacement, but at a time t, is equals to t, we're saying that it will come to a point where the displacement in the y direction, y is 0. So what is t minus x over vp? So for example, if you have a wave that is over here, okay? It's starting off like this. Okay? And you're saying that its initial here, it's, well, cos wave to kis tarah se shuru hota hai? We're assuming that this is the distance it's taken. We will go back to 0. This is the time it has moved this much distance in time t. So if we're saying that this is the phase velocity of the wave, the velocity of the wave, then multiplied by time, you will get the distance that it has traveled in the horizontal direction. This distance is given by x. This distance is given by x. Okay? So what we said before is that we defined the wave equation to be y is equals to a cos 2 pi f times time. We said before that y is equals to a cos 2 pi omega 2 pi f into time, right? Omega t 2 pi f times time.
सही मैम
Yeah,
मैम ये जो आपने अभी फार्मूला लिखा है
yeah.
हम इस फार्मूले को अकॉर्डिंग टू अपनी नीड आगे फर्दर मॉडिफाइड करने जा रहे हैं ना कि वो हमें एम्पलीट्यूड भी पता है और एक्स डायरेक्शन में जितना डिस्प्लेसमेंट हो रहा टाइम कवर किया वो भी हमें इंफॉर्मेशन दे
हमें ये चाहिए. हमने अभी तो सिर्फ y को relate किया time के साथ, but y is also related with x also. Like if there is a wave, it's
सही
moving in this direction. Y is also dependent on x as well as time. So we want to get a formula for y in terms of time as well as in terms of x. And in this we have, this is our y direction, the horizontal, the vertical displacement, and this is our x, which is our horizontal displacement. Like as we said
मैम
before, yeah.
एक्स डायरेक्शन में जो मूवमेंट है वो फिर आप एक पर्टिकुलर पॉइंट को कंसीडर करके करेंगे ना कि भाई एक वेव जनरेट हुई है उसके ऊपर एक पॉइंट है वो अलोंग
Yeah.
वाई इतना उसने मतलब डिस्प्लेसमेंट कवर किया और पर्टिकुलर टाइम वो ओवर अ टाइम
Yeah, it's
वही जो
time.
पॉइंट है एक्स डायरेक्शन में इतना आगे प्रोपागेट कर चुका है
Yeah, like for
ओके
example, like
सही
at
मैम ओके
TK, you got it? Okay. So what we're saying here now is that T, what will be T minus, ये जो हमारा formula आया है, T minus X over VP. T minus X over VP, you will have the
Zero.
same displacement.
मैम 0 हो गए.
What are they saying here? They're saying that the value of y will be the same. The value of y will be the same whether you put t minus, if you put t minus x over vp, what will you get? ये 0 होना चाहिए.
Yes मैम
मैम
यस
0.
मैम ये 0
मैम हम लोग एक्स में एम्पलीट्यूड फाइंड करना चाह रहे हैं एक्स डायरेक्शन में
x में जितना distance है वो x होगा. जिसमें horizontal distance has, the wave has traveled a horizontal distance x. It's propagating now. For example, if we have a water wave, यहाँ पे आपने एक stone, यहाँ पे wave water है, ठीक है? यहाँ पे आपने एक stone फेंका है. So what's going to happen is going to go like this and this. The water is going to travel like this and this, right? Right? So इस direction में भी आपका motion है, wave का motion. इस direction में आपका y direction में motion है, और time is also passing. Time is also passing. It's increasing with, like, this is passing. So you want to find an equation for y in terms of time as a function of time and as a function of x.
मैम
Yeah.
एक चीज समझ नहीं आ रही क्योंकि मतलब फंक्शन ऑफ टाइम एंड बोथ एक्स क्यों होगा. अगर फॉर एग्जांपल हमें सिर्फ एक्स मिल जाए तो फिर भी हमें वाई मिल जाएगा, या सिर्फ टी मिल जाए फिर भी हमें वाई मिल जाएगा. ये जरूरी है कि हमें टी और एक्स दोनों मिले, क्योंकि जो एक्स है वो फंक्शन ऑफ टी है, तो सिर्फ टी मिलेगा तो हमें एक्स भी मिल जाएगा, वाई भी मिल जाएगा। इसका मतलब है सिर्फ हमें टी मिलना चाहिए तो हमें वाई भी मिल जाएगा। जरूरी
For
कि हम
example,
एक्स
if
भी
you
हम
look at
include-
these diagrams, ठीक है, like यहाँ पे, for example, a given time t, at a given time t, if we have a stretched spring, a vibrating string, so it's going from starting from this amplitude, it will go here and here and here, up and down, ठीक है. So the x is, what's happening to x is that x यहाँ पे change हो रहा है और time change नहीं हो रहा, तो हमारे पास displacement हो रही है y direction में, up and down, ठीक है. इस ग्राफ में x is remaining the same, time change हो रहा है, फिर भी y displacement हो रहा है, which according to this equation, what
मैम
we want, नहीं आ रही?
मैम समझ आ गई। इसमें मतलब ये है कि x इक्वल 0 का मतलब है कि उसी सेम पॉइंट पे जो है ना
पोजीशन पे टाइम
हाँ,
की वजह से चेंज हो रहा है, अप एंड डाउन,
अप एंड डाउन चेंज आ रहा है, ठीक है।
या
और
अप एंड डाउन.
यस मैम,
Here
और
it's
जहाँ पे
changing
t
in
इक्वल टू 0 है जी, जहाँ पे t इक्वल 0 है, इसमें है कि पूरी वेव मिली हुई है, तो उसमें x किस पोजीशन पे, x रिस्पेक्ट टू x, y की पोजीशन क्या है?
Yeah, उससे like at a given time, at the given at fixed time, x displacement से हमारे जो ऊपर नीचे हो रहा है वो हम calculate. This is what this wave is showing us. So we want basically a graph that will show an equation that will be related to, that will give us y in terms of t and x. So now what we're saying is that the displacement y of the string at any time x at any time t is exactly the same value of y at x is equals to 0 at the earlier time. So if we say t is minus x over vp, what will we get here? We will get the same displacement, like y. Let me erase.
एक्सक्यूज मी मैम,
Yeah.
ये जो आपने लास्ट पॉइंट अभी बोला ना t माइनस एक्स डिवाइडेड बाई वी पी, इसकी समझ नहीं लगी थोड़ी.
Okay, that I will tell you right now, ठीक है? So if we have a cos, यहाँ पे क्या था, omega t, ठीक है? And we're saying that this will be equal, the value of y at x is equals to 0. X is equals to 0. अगर हम यहाँ पे 0 डाल दें, we will get a cos 2 pi ft, which is the same thing as what we had before, this equation, if x is equals to, at x is equals to 0. So now what we're saying is that at the earlier time, which is t minus this time interval, which is x over vp, t minus is obviously 0, right? That's 0. So at 0, it was a given displacement. At t, at time t, it's another, the same displacement again. So can I equate those two equations then? By simply replacing t in equation 3.4 with t minus x over vp, we have the desired formula giving y in terms of both x and time. Because this is like, it's a periodic function, right? Like this distance over here, the time, whether it was time or a time minus this time, it has taken to move this much distance. The displacement यहाँ पे भी same है, यहाँ पे भी same है. So we're going to get, the wave formula, it will be the same. It will be this formula now. We will, instead of time, we will replace it by time minus t minus x over vp. Because the displacement will be the same at this t time and at this time. Is that making sense?
एक्सक्यूज मी मैम, ये जो पहला t है ये मतलब बिल्कुल इनिशियल पे है ना, मतलब जब वेव स्टार्ट हो रही है, ये उसको रिप्रेजेंट कर रहा है, और x डिवाइडेड बाय vp जब वो एक पार्टिकल x डायरेक्शन में मूव कर चुका है, कितना टाइम उस पे स्पेंड हुआ है, वो है.
T is how much time it has taken to move a certain distance. Like it can be 0, it can take a range of values. T is our variable here. T is not it's not a constant number or anything.
मैम
It's not
t को कैसे रिप्लेस कर सकते हैं? इस तरह तो वो तो 0 हो रहा है ना, t माइनस एक्स और vp तो 0 हो रही है ये वाली साइड के साइड.
But x is also varying, t is also varying. ठीक है? X is also a variable, t is also a variable. So x over vp,
हम
it
ये
can
जीरो
take
नहीं
a
हो जाएगा t minus x और vp
क्या हो जाएगा?
जीरो नहीं हो जाएगा
But x is also a variable here. If x was
मैम
0,
इस
we would get the same
वो
equation again.
मैम वो
x
मैम
को
इस
इक्वल करके vpt से ही तो इक्वेशन निकाली है हमने तो उसी से
उसमें we would get cos 0, which is the amplitude, which is the time, like at time t is equals to 0, the x was also 0. So we would get cos 0, which is a, and that would explain our amplitude in the beginning. But this is wait a minute. We
मैम
draw
वो
our wave.
मेरे ख्याल से शायद चाची भी कह रहे हैं कि वी टी से मल्टीप्लाई होके दोबारा एक्स ही बन जाएगा ना, तो एक्स और एक्स कैंसिल हो सकते हैं.
You mean that x is p over t? So t or t was 0 हो जाएगा ना? But the thing is that t is varying, x is also varying. So
किसी
it's not always
से मैम वो कैंसिल हो जाएगा और उस वक्त एम्पलीट्यूड जीरो हो जाएगा, यानी y की वैल्यू जीरो हो जाएगी.
a
लेकिन
होगा
बाकी
because cos of 0 is 1. Cos of 0 is 1, so we would get this point. Now, for example, we have this point over here, which is यहाँ पे हमारा क्या होगा? What will be our, for example, if t omega यहाँ पे क्या होता है? Our angle that we have moved is what? This is यहाँ पे pi. This is pi over 2, right? Pi over
Yes,
2. Pi over 2. So if we put pi over 2 in this equation, what will we get? 2 pi times frequency, 2 pi times frequency time into t minus what? Omega is equals to 2 pi f. 2 pi f, ठीक है? For example, the time and the position here both are varying. That's what we're saying here. So we can write an equation that looks like this because this equation will satisfy this equation, basically. Not making sense? Yeah?
मैम
Suppose
ये
that
वेव फॉर्मूला मैम ये कहाँ से है? वेव फॉर्मूला लिखा हुआ ना यहाँ पे y is equal to a cos 2 pi v 2 pi nu, ये कहाँ से है?
that is a general form for a sinusoidal wave, right? Either it's a sine omega t or a cos omega t, right? A general form of a sinusoidally moving wave.
जी मैम ये ठीक है मैम, लेकिन मैम वहाँ पे वो जो प्लस x ओवर vp है वो कहाँ से है? जो माइनस x ओवर vp.
X over vp. Okay, so let's try to explain this again. So if here we're saying that time is 0, but x is moving. For example, यहाँ पे time is stationary. So x is moving in this direction. So if we have a given x, यहाँ पे time is 0. तो अगर आप ये equation देखेंगे, तो time 0 हो जाए, not this equation. So time is 0, but x is varying. So you will get minus cos 2 pi omega 2 pi f times minus x over vp. And x over vp is time. Is the same as we said, x over vp is the time t, right? So and then cos minus of time is obviously the same thing as cos of time. So we get the same equation back. Is that making sense? And then if you talk about this equation, just x is 0, but time is varying. X is 0, time is varying, then we get also the same equation back. Is that making sense? So at one point, we're varying one of them. Like this equation is showing this one, in which we're varying the x, but not the time. We still get the same equation back. This equation is that at x is 0, we get, but this time is varying, we get the same equation back. So this equation does hold. This equation is true. We're saying basically that the displacement at this point and this point are equal from at time t is 0 and at time t is equals to t. So we get this equation.
Yes, ma'am. समझ आ गई.
Excuse me, ma'am.
Yeah.
Excuse me, ma'am.
Yeah.
मैम ये जो t माइनस एक्स डिवाइडेड बाई वी है ये असल में इंटरवल शो कर रहा है ना, फर्स्ट टाइम और इनिशियल
Yeah.
फाइनल टाइम।
The interval between
फाइनल
the
टाइम को
latest.
हमने मतलब
Yeah.
एक्स डिस्टेंस की फॉर्म में लिखा हुआ है।
X is the horizontal distance. Yes. ठीक है?
तो मैम ये मतलब जो जब हम इंटरवल फाइंड आउट करना होता है तो कोई भी फाइनल माइनस इनिशियल करते हैं तो ये थोड़ा बहुत आगे पीछे नहीं होना चाहिए। लाइक मुझे वो समझ लग गई है कि ये इंटरवल शो कर रहा है, लेकिन अब
Yeah.
जिस तरह होता है ना वी एफ माइनस वी आई करते हैं आप कोई भी इंटरवल निकालने के लिए, तो एक्स डिवाइडेड बाय वी पी ये हमें फाइनल टाइम शो कर रहा है जब एक पर्टिकुलर पॉइंट ने एक्स
Yeah.
डिस्टेंस कवर कर लिया है तब उसने कितना मतलब यानी कि टाइम हो चुका था, तो एक सेंस के अंदर ये फाइनल टाइम आता है। तो
और
ये
ये
माइनस टी नहीं होना चाहिए था।
क्यों माइनस क्यों है आप पूछ रहे हैं ये?
नहीं ये सिर्फ ये इंटरवल नहीं है, ये मतलब ये टी माइनस एक्स वी पी में वो टाइम दे देगा जब वेव ने स्टार्ट किया था ट्रेवल करना, जब बिल्कुल इनिशियल उसका पॉइंट था, जो इनिशियल पॉइंट पे जब वेव ने स्टार्ट किया था वो टाइम, ये टाइम ही है असल में, सिर्फ एक टाइम मिल जाएगा वो वाला जब उसने स्टार्ट किया था ट्रेवल करना। तो मतलब जब उसका उसके पास यहाँ पे इसी इसमें ये जो वेव ट्रेवल कर रही है इसमें जो स्टार्ट करती है तो उसका जो डिस्टेंस होता है उसको पहले ही वाई होता है, जब दोबारा हमने एक्स पे किया तब भी उसका डिस्टेंस जो उसने जो y होगा वो भी तब भी सेम होगा, इस टाइम पे t पे भी सेम होगा और t माइनस एक्स पे भी सेम होगा, क्योंकि ये उसका वो है मीन
Yeah,
पॉइंट एक तरह से।
basically that's what we're saying. The displacement is the same at this time and this time. And basically, if we put these limiting cases in here, it's basically, it's solved, right? Because at t is 0, what's going to happen to this wave? It will be just cos of 2 pi f times x over vp minus x over vp, which is equals to x over vp is time. So, and minus cos of minus of x is equals to cos of x. So, फिर Baki, it'll get back to the same equation, which is a cos 2 pi ft. Similarly, if we put this equation in here, x is 0 in here, we will also get back the same equation. So this is our definition, and we can use this definition to say, we know that 3.5, this equation reduces to 3.5 at x is 0. That's exactly what we just said. And then 3.5, this equation can be rewritten. Now we know that we have a formula for Vp, c square over v. No, actually Vp we know is equals to 3.5 may be rewritten, since the wave speed is given by frequency, the phase velocity is given by frequency into wavelength. तो यहाँ पे phase velocity की जगह आप frequency into wavelength डाल दें, frequency into
मैंने बस
wavelength.
मल्टीप्लाई किया है अभी इसमें सिर्फ मल्टीप्लाई किया है उसको फ्रीक्वेंसी को।
या इस स्टेप में ये जो फ्रीक्वेंसी है ये यहाँ पे मल्टीप्लाई कर दिया, यहाँ पे भी मल्टीप्लाई कर दिया, और फिर यहाँ पे फेज वेलोसिटी डाल के the frequency and frequency will cancel out and we get just x over lambda. 2 cos 2 pi frequency into bracket, not into but bracket, frequency times time minus x over lambda. So this will be unitless term, right? Because frequency is 1 over second and time is second, so second and second will cancel, and x is in meters, lambda is in meters, so it's unitless. So radians तो इसी तरह होता है, ठीक है? So anyway, so we also know that omega is 2 pi f, and then k, we define a wave number k, which is defined by 2 pi over lambda. ये सबको पता है ये k कहाँ से आया है? ये आपने waves and oscillations में पढ़ा होगा, ठीक है? Define k as 2 pi over lambda. So then if you put 2 pi f, basically this 2 pi is equals to omega over frequency. So this will be omega over frequency times lambda, and frequency times lambda is a wave phase velocity. So we get omega, k is equals to omega over phase velocity. So the unit of W is a radians per second. What is the unit of W? If it's an angular velocity, right? So it will be radians per second. And K is radians, which is this one, divided per meter, because lambda has a unit of meters and 2 pi has, this is in radians. So we have radians per meter. So basically what V is saying over here, V velocity P, the phase velocity is omega over k. So uske units kya honge? We have radians per second and radians per meter. So it will become what? The units of velocity will be what? Radians per second divided by radians per meter. So it'll be meters per second. So basically, again, we get the same. We confirm that these equations are correct because we get the same unit for our speed, which is meters per second. Okay, and v times per second. Wait, a particle that moves around a circle, v times per second sweeps out how many radians? So if there's a circle and a particle is sweeping this circle in a velocity with a velocity of v times per second, how much radians does it swipe per second? Obviously 2 pi v. We're going to multiply because it swipes v circles per second. So v times 2 pi radians is how much it will swipe in 1 second. Radians per second. Okay? So then our equation now, because we have, our equation was what? Y is equals to a cos 2 pi ft minus x over lambda. And then we are saying that we already know that 2 pi, wait, what just happened? Okay, 2 omega, where'd it go? Here, 2 pi f is omega, so we can take that as omega, and then 2 pi x is our, 2 pi x is what? K is omega over Vp. So where we had that equation, 2 pi x, this term will be 2 pi x over lambda. So 2 pi x over lambda will be k, basically kx. ठीक है, so ये हमारे पास ये equation आ गई. सबको समझ में आ गई ये कैसे equation आई है?
Yes, ma'am.
Okay, so in 3 dimensions, k becomes a vector k normal to the wavefront, and x is replaced by the vector r. If we have 3-dimensional, this is for a 2-dimensional wave, okay? Where we have the y direction and the x direction. But if it becomes in 3 dimensions, where we have the y, x, and the z, then we have to write it in terms of vectors. But we won't be doing that. We won't be going into the vector.
मैम वेव जो है वो 3 डायमेंशन में हो सकती है.
Wave 3 dimension में किस तरह से हो सकता है? In 3 dimensions, k becomes a vector k normal to the wavefront. That is, that would be a different situation, but we are not going to go into that situation. But wave 3 dimension में किस तरह से हो सकती है?
Yes, ma'am, ये पूछ रहा हूँ किस तरह से हो सकती है.
Electromagnetic wave.
मैम
3 dimensions.
वो इलेक्ट्रोमैग्नेटिक वेव में सिर्फ सिंगल वेव नहीं होती, वो दो वेव होती हैं जो मतलब
और मैग्नेटिक फील्ड होती है at right angles to each other.
Yes, मैम, वो दो वेव होती हैं. तो एक सिंगल वेव हो सकती है मतलब.
Single wave in 3 dimensions, if we try to imagine it, how can we imagine it? 3 dimensions, it seems like we can't. It will, like, अगर ऐसे wave move कर रहा है, ठीक है? It has a component in the z direction, component in the y direction, component in the x direction. Component से करना पड़ेगा ना? Like if the amplitude is in the y direction, amplitude, but it's moving at, but this is weird because we can define this as the x-axis, right?
Yes, ma'am. Yes, ma'am.
But I mean, if you have an axis that is like this, at some angle to the velocity propagation angle, if you're considering 3 different waves moving at 3 different, and you define the coordinate system such that this wave is moving at some angle relative to the x direction or the y direction, then we would have like the components of the vectors. Yeah?
Okay.
Okay, so amplitude of de Broglie wavelengths correspond to a moving body. A group of waves need not have the same velocity as the waves themselves. So what's the difference between phase velocity and group velocity is that if you have a wave group, okay, a group of waves here, they will move at, you can take one point on this group, and the whole group will move with that velocity. That is called the group velocity. But it's not necessarily equal to the phase velocity. The phase velocity is the velocity at which, like as I showed you this video here. So this is our phase velocity, the velocity of the whole wave. But the group velocity is the velocity of the group only. Is this making sense? according to this diagram. And how do we get a wave that looks something like this? We do superposition of different waves. Two different waves, for example. उनकी addition like amplitudes कहीं पे add हो रही हैं, पे subtract हो रही हैं, तो इस तरह से हमें एक pattern मिल जाता है. And we're going to derive the formulas as well. We're going to derive formula for a wave that looks like this. इस तरह का जो, yeah.
टाइम हो गया.
इतनी जल्दी?
Yes, ma'am.
Why?
पता नहीं, काफी
दूसरे
टाइम हो
स्टूडेंट्स चाह रहे होंगे, दूसरे स्टूडेंट्स पढ़ना चाह रहे होंगे.
हम पूछ रहे हैं सबसे, मुझे लगता है टाइम हो गया, तो वैसे क्लास का टाइम खत्म हो गया.
A group of waves need not have the same velocity as themselves. Yeah. So ये समझ में आ रहा है?
स्लाइड एड कर ले.
हाँ?
ये वाली स्लाइड कर ले फिर उसके बाद.
Yeah, okay. So this is the difference between phase velocity and group velocity, ठीक है? So to mathematically describe a wave group in terms of superposition of individual waves at different wavelengths. So if you have two waves, like as shown by this video here, if you have two, they have different frequencies, they have different wavelengths, ठीक है? ठीक है, they have different velocities, जो भी हैं different उनकी differences हैं, तो उनकी जब superposition होगी, when they're moving in like superposition होगी, some places their amplitudes will add, some places their amplitudes will subtract, so we will get something that looks like this. And we're going to derive the equations for these as well. ये फिर हम कब है next class हमारी?
Monday का.
Yeah, Monday. So a way to mathematically describe a wave group is in terms of superpositions of different waves of different wavelengths. जब वो interfere करेंगे एक दूसरे से, तो there will be a variation in amplitudes that will define the group shape. ठीक है, the velocities of the waves are the same, and the velocity with which the wave group travels is the common phase velocity. Basically, if the velocities, दोनों waves की velocities same है, then we will see that the velocity with which the wave group travels is the common phase velocity. And हम calculations करेंगे, ठीक है, derivations करेंगे इसमें, फिर हमें ज़्यादा पता लगेगा कि phase velocity कब same होती है group velocity से और कब difference होती है, ठीक है? So we get dispersion. As a result, the wave group has a velocity different from the phase velocities of the waves that make it up. If the phase velocity varies with the wavelength, the different individual speeds do not proceed together, ठीक है? So if the phase velocity varies with wavelength, ये फिर हम next time कर लेंगे dispersion. ये थोड़े से YouTube के links मैंने यहाँ पे लिखे हैं. I would recommend you to watch these because they would show you the difference between phase velocity and group velocity, ठीक है? इस slide से हम फिर Monday से करेंगे. ये slide हमने कर लिया है और यहाँ से हम group velocity की derivation हम करेंगे, ठीक है? ये सारा करेंगे next class में. और फिर उसके बाद we have other topics like particle diffraction, particle in a box, and uncertainty principle 1 and 2. This is part of the chapter wave properties of particles, and then we will do quantum mechanics, and then we will do other chapters as well. ठीक है? Any questions?
No, ma'am.
Any questions? No? Okay.
मैम ये थोड़ा सा मैम ये समझ नहीं आया वैसे phase velocity और group velocity.
Phase velocity और group velocity, if you look at this, like एक तो मैं ये बता रही हूँ कि अगर आपके पास दो waves हैं, ठीक है, दो waves हैं जिनकी differences हैं in their wave function. This is the first wave, cos omega 1 t minus k1 x. Time is a variable, x is a variable. We don't assign 1 or 2 number to those. यहाँ पे लिखा आ रहा है, ठीक है? This is our y1. y1.
मैम.
Yeah.
मैम. समझ आ गया वैसे थोड़ा बहुत, लेकिन ये है कि अगर दोनों की स्पीड सेम होगी, जो वेव्स हैं दोनों दो वेव्स हैं इनिशियल वेव्स, दोनों की अगर स्पीड सेम होगी तो फिर जो है वेव ग्रुप वेलोसिटी और फेज वेलोसिटी सेम ही होगी.
It's written here, if the velocities of the waves are the same, the velocity with which the wave group travels is the common phase velocity. Yes. However, if the phase velocity varies with wavelength, कि अगर आपका जो wavelength है, wavelength के साथ, with the wavelength of the wave, किस तरह से wavelength of the wave के साथ phase velocity vary कर सकती है? as a function of
मैम
the wave.
ये जो इब्राहिम ने सवाल पूछा है
Hmm?
इसमें ये अगर वेलोसिटी भी सेम है और वेवलेंथ भी सेम है तो ग्रुप वेलोसिटी नहीं होगी, क्योंकि जो एज अ रिजल्ट जो नई वेव बनेगी वो टोटली उसके अंदर क्या होगा, कंस्ट्रक्टिवली इंटरफेरेंस हुई होगी, कोई डिस्ट्रक्टिव टाइप होगा नहीं, सारा सुपरइम्पोज होगा ना, मतलब एज अ रिजल्ट एक हाई वेव बनेगी, उसमें ग्रुप होगा नहीं। उसमें सिर्फ जो जो ग्रीन कलर का जो डॉट शो कर रहा था वो साइकिल की जो वेलोसिटी होगी, एक साइकिल की वेलोसिटी वही शो होगी, उसके अंदर ग्रुप नहीं बनेगा।
Yeah.
ये अगर
ग्रुप बने
वेवलेंथ थोड़ी
If
आगे
the green dot is equal to the if the green dot is equal to
हाँ
the
ऐसे ही
magenta,
होगा शायद।
what will it
ग्रुप
represent?
बनेगा लेकिन वो सेम ही होंगे, एक ही जगह पे दोनों पॉइंट होंगे, ग्रीन और पिंक
Green or
सेम ही
वही
magenta
जो
होंगे।
एक
इंडिविजुअल साइकिल ही हाई हुआ होगा ना।
हाँ सिर्फ मतलब साइकिल
हाँ
एक ही होगा।
या cycle
हम्म।
एक ही हो, ठीक है? So we will do this
अच्छा
one
मैम
in
मैं
more detail.
यस मैम
Yeah.
मैम मैं ये पूछ रहा था, मैं अगर दोनों वेव्स की स्पीड डिफरेंट डिफरेंट है, ठीक है, तो ग्रुप की स्पीड कैसे निकलेगी फिर?
वो हम कैलकुलेट करेंगे ना सारे, ये सारा कैलकुलेशन इसके बाद यही करेंगे
हम
हम।
कल कह रहे हैं डेरिवेशन कल करेंगे, हम कल डेरिवेशन।
ओके ठीक है।
डेरिवेशन
मैं इंट्यूशनली पूछ रहा था, मैं कोई वो फॉर्मूले से नहीं पूछ रहा था, लेकिन चलो ठीक है।
पहले फॉर्मूला करेंगे उसके बाद इंट्यूशन करेंगे ताकि उसे ज्यादा अच्छी तरह से समझ में आ जाएगा, ठीक है?
यस मैम ठीक है।
Okay. Anyone else want to mention anything or say anything regarding the topic?
एक्चुअली मैम
Yes.
मैम ये स्लाइड नंबर 18 पे हमने वेव नंबर पढ़ा है। वेव नंबर ये होता है ना, मतलब
K
वेव
equals to
पर
lambda is
लेंथ,
yeah.
मतलब एक पर्टिकुलर लेंथ में कितनी नंबर ऑफ वेव्स आ रही हैं।
एक 2 pi revolutions होती हैं. 2 pi is the one for one revolution, right? For one wave.
मैम
And
वेव नंबर तो ये नहीं
radians
होता कि वेव लेंथ पर यूनिट लेंथ, यानी कि पर मीटर उससे रिप्रेजेंट करते हैं किस तरह।
radians per meter है उसका unit, meaning
मैम
that
एक्चुअली ये जो यहाँ पर लिखा हुआ ना k इज इक्वल टू 2 पाई डिवाइडेड बाय लैम्डा, ये किस तरह में वेव नंबर को रिप्रेजेंट कर रहा है, मतलब यानी कि वेव नंबर जो हमने पीछे एफएससी या पीछे जो पढ़ा हुआ है वो यही होता है कि कितनी वेव लेंथ आ रही है, कितनी नंबर ऑफ वेव्स आ रही है पर यूनिट लेंथ। तो ये 2 पाई तो एक साइकिल होता है ना, साइकिल पर वेव लेंथ, मतलब यानी कि सेंस ये क्लियर नहीं हो रही।
unit of k is radians per meter, ठीक है? कि आपने कितने radians एक मीटर में कितना, like 2 pi is a number of is the amount of radians that you move in one wavelength. The one in a unit wavelength, like for example, if the wavelength is 10 meters, 2 pi over 10 will give you a number, which means that this is the number of radians I have moved, the wave has moved in 1 meter of the wave. 1 meter. If the wave has moved 1 meter along the x direction, then this is the amount of radians it has moved, it has traversed, like radians में. Like for example, अगर ये है हमारा wave और ये है 10 meters, we know that this 10 meters corresponds to, this 10 meters corresponds to 2 pi radians. Yes? This 10 meters corresponds to 2 pi radians. So 1 meter,
Yes, ma'am.
1 meter में कितना radians हमने cover किया है? That's what they're saying. That's what K is.
ओके मैम।
Okay. Anything else? Let me download the attendance list as well. Okay. So if there are no other questions, then we will continue on Monday, and I might give you an assignment either tomorrow or on Monday. ठीक है? I know that all of you, none of you want to get any assignments over the weekend, but if I give it to you over the weekend, then it will be due after 1 week since from the time I give it to you. So I will probably give you some questions to solve, okay, related to relativity most likely, or to this beginning of this topic. We haven't finished this topic yet, so most likely relativity पे. Is that okay?
मैम नेक्स्ट वीक दे दें, फिर नेक्स्ट वीक
week.
हमसे लें।
Okay, so अगर दूंगे तो फिर Monday को दे दूंगी, या Monday या next week में. Then it will be
Yes.
due 1 week afterwards.
ओके मैम।
ओके मैम।
Okay.
मैम आपने ये वाली
काफी
स्लाइड
टाइम है।
शेयर की हुई है जो जिससे अभी आप
Yes, I
पढ़ा
have.
रही थी?
Yes, I have. Let's check.
आपने
Files.
इसी के नाम से एक
मैम
स्लाइड
उसमें
शेयर की हुई है
वीडियोस भी
लेकिन
हैं।
मैंने ये वाला शेयर किया है. Modern Physics Lecture 1.pptx. This the one that I have used today. Lecture 1.
आपने
ओके
एक और
मैम।
स्लाइड शेयर की हुई है इसी नाम से जिससे आप पढ़ा रही थी, लेकिन उसमें काफी ज्यादा जो आप पढ़ा रही हैं वो नहीं है। लाइक उसमें ये वेव्स का मेरे ख्याल से नहीं है।
ये वाला है. ये Lecture 2 है. Lecture 2, you mean all these topics? These topics? This is in lecture number 2. PowerPoint number 2.
ओके मैम।
Particle diffraction and all these topics. And uncertainty principle and those topics. ठीक है? Particle
मैम ये आपने कहाँ
diffraction.
पे शेयर किया?
ये सारा class जहाँ पे class materials है, files, modern physics files, class materials, इसके नीचे सारा book है, और ये video थी जो मैंने आपको दिखाई थी, is MC square, Minkowski diagrams का PDF, और ये introductory PowerPoint. This is the one we did today, we're doing today, and this is a later one, and this is relativity. ठीक है?
जी मैम ठीक है।
Okay.
मैम ये क्लास शिफ्ट कर सकते हैं हम सुबह के टाइम?
I don't know. I don't know about that because I have other classes in the morning and it's difficult to change the timetable all the time. But I will see if it's possible or not. ठीक है?
ओके मैम, अल्लाह हाफिज़।
Hafiz. Hafiz.
अल्लाह हाफिज़।